Hey everyone, good evening. I hope you're all doing well. It's good to be back on the stream. So Monday night should now be a semi-regular occurrence. And today I thought I'd be follow what everyone else is doing and do some Elm, and in particular do Advent of Code in Elm. So I'm sure Advent of Code needs no introduction. It's the yearly coding problems advent calendar. It's great fun. Really recommend it. You can do it, trying to do it in the shortest time possible to get points and do on the leaderboard. I normally use it each year to try a different programming language, either a new one I haven't used before or one that I would like to try and experiment with. What I like about these problems is they're a bit sort of programming challenging, but there's also a good amount of like reading and understanding the problem, which I've always found to be really nice. They don't feel quite so sort of algorithmy as say like leak code questions or something. So I think they're a really good way to practice. This year I thought I'd go back to a language I used to use a fair amount at previous jobs but don't currently, which is called Elm. It's a little functional front-end language designed for building reliable web apps. We won't really be using the web app portion today. We'll just be writing some Elm to pass some tests in order to confirm that that I've got the implementation correct. I'm going to start on day one. I'm going to be online maybe for an hour and a half or so from here on in. So I'm hoping that maybe we'll hopefully make it beyond just day one and get into maybe day 2 or 3. And I know there are lots of people doing this on YouTube, blogging about it on Twitch. So I'm not going to spend loads of time on introducing question 1. But what we have to do here is the elves, obviously very Christmas themed. The elves have written up the calories of food items. Let me zoom in here. And so we have this big list of input. This is not the real input. This is an example input that we use to test before doing the actual solution. And this list represents the calories of food carried by 5 elves. So the first elf is these 3. Then we have a line break. Then we have this elf who just has this 1 item. Then another elf with these 2 items. Then another elf with these 3. And then one final one at the bottom. So in case the elves go hungry, they need to know which elf to ask and find the elf carrying the most calories. So find the elf carrying the most calories. How many total calories is that elf carrying? Because you see here, the real puzzle input is, it's very long. So there's no way you could manually do this. That's why they always give you a sample input, which you can work through and work with. So we're going to implement this using this test input, and then I'll plug the real input in. So we know here the example above, we're expecting this 24,000 calories, which is what presumably this elf is carrying. So what we need to do is we need to take this input and we need to actually structure it into some data where we know how many calories each elf is carrying. And so we're going to dive into some Elm. I'm going to kind of talk through bits of Elm as I go. If there are any bits you don't understand or haven't seen, or you would like to ask questions, please feel free to put them in the chat and I will make sure I answer them. So this is what Elm looks like. If you've ever done any Haskell, it'll look a little bit similar to that. And on the right, we have some tests. So what I have done is I've pulled in this day 1 input. So you'll recognize this input here as the exact input that we have on the Advent of Code website. And then what we're going to do is we're going to implement this. So I'm going to go into main.elm. I also have this test for day 1. I've just got test.testworks, which is bad. Anyway, we know that the answer we're expecting is 24,000. And if I run this test, it will error. And it's going to say that we expected 24,000, but we got 1. So that's fine. Output is, it's a bit of a shame that output goes off the screen like that. That's definitely a bug in my Vim plugin that I've written, but we'll ignore that for now. We need to make sure that we deal with that correctly. I'm just going to write a note for myself. Need to limit the max height. Anyway, maybe I'll do another stream on some Lua MVim plugins at some point. Okay, so we have our input in that day 1 module, so I'm going to import that. So the way, if I just look at that, here we go, inputs. So this Elm module is called inputs.day1. It's because it's in a folder called inputs. So we're going to import inputs.day1. And I'm not going to expose anything, but I'm going to call this as day 1. And so now what I can do is I can I can now refer to day1.part1sample, and that's going to be this string. And think about this, we have this list, and we know that an empty line signifies the end of one else total. So what I want to do really is end up looking for something where we have an array of numbers, where each number is the amount of calories for one elf. So we can go through the list, and when we get to a new line, we know that we need to start a new item in the list. Otherwise, anything previously, we sum into the current item at the tail of the list. Thinking about it in Elm lists, it's much easier to get the head rather than the tail, because I believe they're implemented as linked lists under the hood. So we will probably do it that way. And this is where I give you a big disclaimer that I am rusty with Elm, so I will be looking up documentation quite a lot. And so to start with, we're going to look up Elm lang list, and we can look at this list module here. And what I'm looking for is the reduce function, but I know in Elm it's not called reduce, it's called fold left. There's also fold right, or foldle and folder, if you like. And this will let us reduce a list from the left-hand side. So this is what I want to do. We can reduce the list down into a list of numbers, and then we can find the biggest number, and that will be the result. So fold takes some form of sort of callback function. Then it returns, then it takes the initial value as input. It then takes the list that we're going to fold over. And then finally it returns something of type B. This here, because it's a lowercase, is a generic. And in Elm, these type signatures, the thing furthest to the right, the last one, is the return value. So I'm literally just going to actually copy this in, and we'll go back into Vim. And in Elm, 2 dashes is a comment. So we'll import list. Okay, so we're going to take day1.part1sample is going to be the input string, but what we need to do is we need to turn that into a list. So what we can do here is we can call list.split. No, there is definitely a way to split a list. No split. Okay. Okay, let's look at transforming it. Oh, sorry, I'm looking on list. We need Elm string.split, don't we? So if we were to go to Elm core 105 string, I'm pretty sure there's going to be a split method here. There we go. Split. Okay, excellent. So it takes in the split character and then the input string, and it will give us a list of strings. So let's work with that. So we need to do string.split, and we'll split on a new line. And Elm function arguments don't need commas between them or anything, so this is perfectly valid. The reason this is moaning is because it's not returning a number, it's returning a list of strings. What I can do is temporarily assign this to a variable, so I'll say input list, it's not underscores, it's not that, and we can say in1. And what that means is we've effectively bound this variable input list, but we're still going to return 1. So if I run the test now, it's erroring. Still, but now we're not, sorry, the Elm compiler isn't erroring, the test is failing because this is returning 1. What I can do here is I can say underscore equals debug.log input, and then input list. I think that's valid, there we go. So you can see here we have the input, and we can see we have it split into strings. You see we have this new line at the beginning as well. So we're going to have to deal with that and likely just ignore that. Oh no, because we can start with an empty list, and then when we see a new line, we'll push the 0 onto it. So actually, that works just fine. Okay, so we have the input list. We're going to log it out. What we might want to do is all the values are strings. We're going to need to turn them into integers, but we're going to deal with that as we go over each one, I think. So what we're going to do is I'm just going to stay doing this code in this let block because it's a nice way to bind effectively variables and then debug log them. But once we've got it working and I don't need to debug every step as much, I will be sort of tidying up, and we'll refactor it once we have the test passing. So we're going to let the result is going to be list.fold left. Don't know why we're getting those documentation twice, but fine. Fold left, and it's going to take the accumulator function, which I'm going to call accumulator. We'll define that in a second. It's going to take our initial value, which is going to be an empty list. And then it's going to take the list, which is input list. So we can say the accumulator, and I can define these functions in this let block. That's fine. It's going to take in, so it's going to take in the string, which is going to be the item in the list. It's then going to take in our current, the thing we're folding over, which is a list of, is it number lowercase? I think it's like that. And we know it's also going to return our list of number. No, it is capitals because else it's a generic. No definition. Oh, of course, because I'm thinking JavaScript, we have int and float, so it's list of int. So now we define the actual body, so it's going to take in our current list item. It's going to take in our let's focus on this list. We call this item and list. And for now, what we'll do is we'll return list. And I've forgotten it equals that. Unused pattern item, that's fine. Let's actually pull this out into there. I don't know why it's moaning so much about that. Is that just the indent? I think it's the indent. Yeah, there we go. Okay. Okay, and what we'll do here is we'll debug.log result. So the result is an empty list. That's kind of what we expected. So what we can say in here is we want to say if string dot is empty item. Then at this point, what we need to do is we need to push a new empty list onto the list. And that will be the one that we then start adding values to. And we can even we need to push a value onto the list, and we can start that at 0. So the way we can do that is we can do list dot, is it append? Plus plus operator also appends list. So I think we can do list with 0 plus plus list. And we'll have an else, and we'll just return the list. If you concatenate two lists, but the first item is a single element, you should use the cons operator. So I think that's saying we can do, is it that? Yeah, there we go. Okay. So that is going to push 0 onto the list. So if I run the test now, see, we know the test is failing, but we can see the result now is a load of zeros, which looks approximately what we want. And we're logging a 0 when we get a new line. Okay, if the list isn't empty, what we want to do is we're going to grab the head of the list, and we're going to add the value to it. So if the item isn't empty, we need to pass it into a number. So we can do case string.toInt. You can see this returns a maybe int. So it's going to return either the number wrapped in a just, or it's going to return nothing if it fails to pass it as an integer. Don't believe in Advent code you ever have to deal with input being invalid, so I think that's fine. So we can say string.toInt item of. If it's nothing, something went wrong, and what we can do is we can just return the list. But if it's just x, where x is some value, then what we need to do now is we need to take the head of the list and add x to it. So we can say, I mean, we could probably pattern match this, but let's just say case list of, and again we're going to match on the list, so we'll say it's got the first and then the rest. For now, we'll just return list, and if there's anything else, we're just going to return list. Is that the right syntax? I'm trying to remember how in Elm you can pattern match the head of the list with the rest of the list. Let's have a little Google. Elm pattern matching over list. There we go, cheat sheet. This sounds about right. Tuple list. It's just F for the thing at the first, colon, colon. Yeah, using the cons operator. Okay. So it's going to be first, the rest like that. It's annoying it can't tell me that that list is, it just says local parameter rather than kind of telling me what it is, but anyway. Oh, that name down there is getting confused with, okay. We need rest there. So what we now want to do is we want to do first plus X and push it back onto the rest of the list. Okay, that's looking quite promising. We have 10,000, 24,000, 11,000, 4,000, 6,000, and this 0 at the end. Remember that we're always pushing things onto the head, so this really is reverse compared to the input. But that looks now like about what we want. I guess like what I could do as well is do something like this. Would that get rid of the first new line? Yeah, oh no, we still do have that 0. And then we get, what do we get there? We get 0, 10,000, 24, 11, and a 4,000. Oh no, we do need that first new line because it's going to, no, what we need to do is we need to do this. Whoops, so let's join that there. I don't want to rely on there being a new line right at the start, so I think we'll join up there. And then what we'll do is when we start our accumulator, we'll start it with the first item in the list already. And that's what we want. Okay, yeah, and then this 0, I suspect the 0 that we get is because the very last item in the list is an empty line. We could deal with that. To be honest, I'm just going to leave that because that's not really going to impact us too much. Okay, oh, and I can add that string there. So we loop over the list. If we see an empty string, we're going to take that as a signal that we're between elves. So we need to finish off the first elf's count and shove a 0 on to represent the next elf. If we don't, then we try and convert the item into a number, which should always work. If it doesn't, we just change it into, we just return the list. We just kind of bail. If it does, we have the number, then we take the list, we pull off the first item on that list, add the number to it, and then we push it back onto the head of the list. Otherwise, again, we just bail and return the list. I have to have that condition because else what Elm is going to say is, whoa, you're matching a list where there's a head item and then some rest of the list, but you're not dealing with the empty list case, so we just need to do that there. I could also write this string to in item differently because there's maybe with default as an option. So what you can do is you can say string.toInt item, then push it on to maybe.with default 0, and that would give us our number as well. You can do it either way, really. I'm just going to leave it like that. Okay, so now we have that. We're not actually done yet because we need to sort the list in descending order. So Elm has a list.sort. I can't remember if you can give it sort of the order in which to sort by. Let's go and have a look. List sort. Sort values from lowest to highest. Okay, sort by will derive property. Okay, so we do have head. Is there a reverse? I mean, we could just sort it and then reverse it, which I know isn't ideal. Yeah, okay. Let's just do that because then we can use built-in methods and I'm not too worried here. Okay, so we have this. Now what I'm going to do is I'm going to pipe. So that will take the result of this expression and push it in. So I'm going to do list.sort. Whoops. Sort. If we run that, it is now sorted. So then we're going to push that through list.reverse. Now we have it like that. Then we say list.head. And that's going to return a maybe. So I'm going to say maybe.with default 0. Let's just bail. And now I think what we can do is if we say return result here. The result value is an int, but the type 1 says it should be a number. Okay, that's, I can replace that with an int. Our success. Okay, great. So that's now working. So what we can do is go and grab the actual proper input. Where was that link? Puzzle input. So we're going to grab that, come back into here, and I'll say part 1 sample, and we'll say part 1 proper. Part 1 proper equals. We've got 2. I've got an auto pairing thing, but it always goes a bit haywire when you're trying to do 3 quotes like that. Yeah, I do want to paste that anyway. Thank you, WSL. And then we're just going to bring that in there. Save that. So what I'm hoping now is I'm going to do part 1 proper. We're going to run it. The test will fail, but we can take now this number, 67,450. Let's paste that in here. Whoops. What was it? 67,450. Right answer. Okay, excellent. So Advent Code always has 2 parts per day. We are up and running though. We have the first gold star. So that's good news. So let's have a look at part 2. By the time we calculate the answer, they've already realized the elf carrying the most calories may well run out. Yeah, to be expected. The total calories carried by the top 3 elves. Okay, so that's still the top 3 carrying the most calories. Okay. I think Elm... So now we don't just want the first, we want the first 3. Elm has list.take, which will take the first n members of a list. So I think we can fairly straightforwardly get this working. So I guess I got day 1 here. I should call this like day 1 part 1. Maybe let's just make sure the tests are still working. And then I know there's going to be some duplication here, but we're just going to press the wrong button, part 2. The input actually hasn't changed, so I'm going to take this back to part 1 sample. Unused top level definition, that's because I need to then expose it. So, I don't know what this is moaning about. No definition found. It definitely is. Okay, so the accumulator is still exactly the same. And now what we want to do is not do list.head, we're going to list.take 3. And then what do we need to return? Is it still the sum of all the calories? How many calories are the top 3 elves carrying? Yeah, okay. There must be list.sum. Yeah. Okay. So in terms of making sure we have a test that works, so I can change this day 1 works to part 1. It seems there's definitely a bug with the Elm LSP here where it kind of loses these definitions for a little bit, but that's only going to trigger me a little, so we'll deal with that. Expect to equal 24,000, but it's going to be this one, 45,000. 45,000. Okay, so day 1, part 1 is failing. That's because we're now running this on the real data, but part 2 is passing. So that looks like we've got that correct. So again, if I now change part 1 sample to part 1 proper, and we run that, we can see that we now should be getting 199,357. Excellent. So that is day 1 done. Perfect. So let's just do this in here. Day 1, lovely stuff. Great. And so one thing I did say I would do is refactor these lets. I'd probably leave the input list here, but what I would do is move this down here, ditch that result equals. We could do that. What we could then do if we really wanted to is we could take this string.split, which gives us our input, and then we could pipe that into list.fold. Oh yeah, and obviously that is definitely invalid code. And there we go. That will still work. When you pipe a value in, it gets applied as the last argument to the next function. So the result of this is effectively being put here as the final argument. That gets then put here, and so on and so forth. So Elm's pipeline operator is a really nice way to take some data and progress through it, mapping it or kind of doing stuff with it at each step. Okay, I can see there are a few folks in the chat. Please feel free to ping if you have any questions about Elm. Still very much getting used to this whole streaming thing, so if the audio isn't good or there's anything I can do to make it easier to view and follow along with, please do just ping me. Okay, I guess we should go on to day 2 then. So day 1, I'll be honest, I had watched a couple of people doing it online, so I had a rough idea what I was going to have to deal with. Day 2, I don't think I have seen at all, so this will be interesting. Let's go to day 2. Rock, paper, scissors. Okay. Okay, so we know rock, paper, scissors. We know those rules. That's fine. One elf gives you an encrypted strategy guide. First column is what your opponent's going to play. A for rock, B for paper, C for scissors. Second column must be what you play in response. X for rock, Y for paper, Z for scissors. Winning every time would be suspicious. Okay, so the response has been carefully chosen. Okay, so we're taking in what our opponent plays, then we're deciding what we play. But we're making sure we don't win every time, so it's not obvious that we're just cheating our whole way through this. Okay, so you were given the following strategy guide. First round, your opponent will choose rock, and you should choose paper. This is a win for you with a score of 8. The total score is the sum of the score. The score for a single round is the score of the shape you selected, okay, plus the score of the outcome of the round. 0 if you lose, 3 if it's a draw, 6 if we win. Okay. Okay, so there's kind of a few parts to this. The first is converting this input into something that makes sense for us. Now we could do this by taking the string, grabbing the first character and the third character and then kind of mapping those. That's probably what I'm going to do. There is an Elm parser library, which is kind of a way to build up regular expressions, but in a more nicely sort of descriptive language. I could do that here. You could map literally on an A and map it to be, what was it? Rock. I think that is overkill, but also would be quite interesting. So what is it? Is it Elm parser? I think I'm looking for. Also, if you are wondering, is this overkill and should we just split on the string and do that side? Yeah, we probably should just do that, but sometimes I do like to kind of deliberately reach for new things I haven't done. So this can parse a point by matching on strings. This is going to be too much. This is probably a bit overkill, isn't it? Okay, so let's take some example input. So we'll go, oh no, that's some text when I was playing with that. Input's day 1, so we'll do day 2.elm. Let's just do that. We need to fix these strings, so we go, okay. Oh, am I getting spam already on the chat? That is very exciting. How do I... All right, I need to explore how to get rid of spammy messages. That's fun. That's exciting. We'll leave that for now. Okay, so day 1. So we'll pull in day 2. I'll go to spec. Can you just have as many of these top level suites you want? So I'm going to call this day 1. Then we're going to go down here and we'll do, oops, day 2. Day 2 part 1. And what was our total score expected to be? Just to make sure I can get the test correct. We'd get a total score of 15. 8 plus 1 plus 6. Okay. Now I need to expose. Actually, if I don't expose day 1 now and I just expose day 2, is that just going to run the day 2 test? Because we don't really need to run those tests. I can't find a day 2 part 1 visible. Yeah, that's fair. Okay. Day 2 part 1. Again, we're going to respond with an int. Let's just put, whoops, just put the number 1 in. Part 1. I'm going to expose day 2 part 1. Okay, and we're saying that 1 does not equal 15. That's definitely correct. Okay. So again, we're going to want to parse our input into something more interesting. So we're still going to want to do this string.split. I think we might want to do that pretty much every single time. So we'll say input lines. And we're going to do day2.sample. We'll still return 1, but we're just going to do okay, so we have inputs A, Y, B, X, C, Z. Oh, hey, Tulga. Thank you for the message. That's nice of you to say. I hope you're enjoying it. If there is anything you want me to repeat or explain, please do put a link or put a message into chat. Okay, so we have these input lines, and these lines are of the form something like A space space X or Y space space Z. Oh yeah, the new AI bot maybe will save us. And I'm trying to remember what we have. A is rock, I think. B paper, C for scissors. And then we have similarly X rock, Y paper, and Z scissors. Is that correct? I have to check myself. X for rocks, Y for paper, Z for scissors. Okay. So we can actually make use of some more interesting Elm features. Day one was literally kind of working through strings of a list of strings. We can actually make use of some Elm types now. So I'm going to want to represent the play, so rock, paper, or scissors. So I'm pushing the memory of my Elm, but I think we say type move. Let's say move, and it's going to be rock or paper or scissors. Okay, so now we've created this move type, which can be one of rock, one of paper, one of scissors. And what we need to do is we need to take these inputs and map them into that. So what I'm going to do is I'm going to say char to move. It's going to take in a char. String.from char. Is there string.to char? Char.from. So a char in Elm represents a single character. Oh, and they get single quotes. Okay, so Elm string to char. Char. Characters from char. A string from a given character, but I want the opposite. To list, string to a list of char. That makes sense. I guess you can't convert a string directly to a single character, so we can do to list and then take the head to grab it. This is probably overkill. I mean, we could just deal with strings that are length 1, but I think it would be nice to represent it properly. So let's do that. So we'll take a char and we're going to return a move. And what we do here is we can map on the char. So we're going to look for X, and that will be rock. We're going to look for Y, which will be paper. I will look for Z, which will be scissors. And we'll do that all over again with A, B, and C. I missed an of there. Okay. So this is going to work, but obviously we don't have cases for all possibilities. The issue here is that we are going to effectively, if we get to this point, we've got an invalid character. So I can't really, what do I do here? Do I just say we return rock by default? We could do that. There is also debug.todo, which is a placeholder and will let me sort of give an error. Deal with invalid input. So Elm makes you deal with invalid input and deal with any potential crashes, which is a good thing. if this was real production code, I would want to make sure we dealt with the case where the input was invalid. In this case, we don't really need to because it's just Advent code. I know that the input will be okay. And so I'm not going to kind of lose the time doing that. And debug.todo lets you get away with it. And it is effectively you telling Elm that if it runs that code, it should crash for you, and that's okay. This isn't, if I was working at a company where we were shipping Elm into production, I wouldn't allow code like this in through code review. But for sort of hacks or little side projects, sometimes it can be fine just to avoid the issue. Okay, so we have each line, and we now need to convert each line, which is a string, into parts. So we already know we have string dot, to char list was the method? Just to list, which is great because we can map on that to sort of then pattern match on the characters. So I can say, for example, I guess we could map over the lines. So let's do list.map. Then we're going to take in the line. So this is how we denote an anonymous function in Elm. I'm just going to return line and we'll do input lines. He says that's how we do this. What's it moaning at me for here? Parsing error on list.map. Okay, let's look up list.map. I've clearly done something wrong. Got list open over here. It's map 2. I don't want map 2, I just want the first map. Filter map, index map, map. Okay. Okay, so that should be working. Oh, it's now decided that it is working. Or has the LSP client just ditched on me? I think that might be more to the case what's happened here. Yeah, okay. Not clients attached to this buffer. Okay, I think my Elm LSP client that provides all this debugging has gone wrong. But that's fine. We can just keep going anyway. And what I'm going to do is I'm going to take this map and we can pass it through to debug.log list. So, for example, if I take each line and I just return the number 1 and we run the build, we just get a list of 11111 or 111, which is great. So what we can do with each line is what we want to say is we want to say string.toList. So we're going to take the line, I'm going to flip it into string.toList. Let's just rewrite that the other way. String.toList line of. And now what I'm going to try and do is match against a list that has 3 things in it. So it's going to have the first move, then an empty space, then the second move. So I'm going to say move 1, followed by an empty space, followed by move 2. And in that case, what we want to do is we want to return, let's return a list now of char to move M1, char to move M2. Otherwise, we'll return just an empty list. Let's just say that. The M1 value is a string, but char to move needs the first argument to be a char. I thought string to list gave us a list of characters. String to list converts a string into a list of characters. The empty value is a list char. Okay, I need like rest here. Okay, so now we have a list of rock, paper, paper, rock, scissors, scissors. That's quite good. rather than represent it as a list, I'm going to represent it as a tuple. So we'll do that. This just means I can like pattern match against it, and Elm will know it's a tuple of two things. It's not going to like this because now we're responding with different types. So what I'm actually going to do is I'm going to say if we parse this list successfully, we'll return just, else we're going to return nothing. Oh, I think, excuse me, I have a dog trying to push their way into my room. Okay, the dog is in the room now. So if we take a look at that, we have these. And now what I can do, if I change map from map to filter map, what that's going to automatically do for me is it's going to keep the values that are just the value and remove the nothings. So now we have this list of rock, paper, paper, rock, scissors, scissors. Okay. So we can say moves is this list. So now what we need to do is take a move into a score. So we can say move to score. And our move is going to be a tuple of a move and a move. And we know we want to get an integer out of the other side. So move to score. And what we can say is P1, P2. Let's just return 1 for now. So we're going to take our moves. We'll stop debugging the moves. Then we'll say scores is list.map move to score, then a move. Our moves, rather. So scores, it's getting a list of 111. So, okay, so now what we need to do is calculate the actual score. So I have forgotten the exact rules for this. Score for the shape you selected plus the score from the outcome of the round. Okay, I'm just going to take this comment. Excuse me, and we're just going to copy it in here, comment that out. Okay, so what we can do here is we can say move point. So it's going to take a move and return an integer. So we say move points move. And so what I say here is case move of, and if it is rock, then we get 1 point. If it's scissors, we get, was it 3? Yeah, I've done that really awkwardly. And paper is 2. Okay, and what we need to do is determine if a given move is a win for us or not. So we are P2. So we can say move result for P2. So it's going to take move, and return. Let's define another type, move result. So we say type move result was win, draw, loss. Move result for P2, P1, P2. Okay, so we now need to do all the work to figure out all the calculations. So firstly, we can check if they're the same. So if P1 is equal to P2, then we know it's a draw. I'm wondering if there's we know how many points a move is worth, and that is also, is that the same ranking for, so rock beats paper. I'm trying to figure out if there's a smart way we can do the scoring rather than a load of if-else statements. I guess we could actually do a massive case statement, couldn't we? So let's change this to just draw. What I'm actually going to do is just quit Vim and open it up to hopefully get some sort of LSP autocomplete going again. And it's all wrong. I think it may just need formatting. Okay, that's fine. Okay, so the only things it's just things being unused. Okay. So let's do a huge case P1, P2 of, and now we can match all the results. So if player 1 played rock and player 2 played scissors, then that is a win for player 1. So that is a loss as far as we're concerned, because we're caring about if player 2 wins. So if player 1 plays scissors and player 2 plays scissors beats paper. I've suddenly forgotten how this game works. And finally, paper beats rock. So those are all losses. If the values are the same, then we know it's going to be a draw. So what we can do is, let's just do that. So we can say rock is a draw. Scissors is a draw. Paper is also a draw. And if we don't get here, the only other conditions are that we won the game, so we could say win. This is one of the reasons I really like Elm is you write quite expressive code here. So sure, people sometimes say that Elm has a lot of lines to it. It's quite verbose. I think in some ways that is true. But equally, if you come here, the logic now is very straightforward to follow, which I've always enjoyed. Okay, so move to score. I don't think we need that anymore, do we? No. Oh, we do. That's what we're mapping. So what we need to do, we know how many points a particular thing is worth. So we know that so let's just do it. Let char points move points for our move. We'll let score points is case move result for P2 passing the two moves of. So if it's a win, we get ourselves 6 points. If it's a draw, we get ourselves 3 points. If it's a loss, we get ourselves 0 points. And I've gotten the in, so let's just say in 1. Okay, and now what we can do is do char points plus score points. Let's run that. So it's npm test. 8, 1, and 6. Awesome. So we can now take these scores, and we're doing that. And what we're going to respond with is list.sum scores. And that's going to give us our 15, which is exactly what we want. Great. Okay, so this is all quite messy. So let's do some tidying up again. So we're going to go there, and then we're going to have a nice little pipe into there, and then we'll have another nice little pipe into score. Okay, and then again we can actually just ditch this. Put another one on here, which is list.sum. Go to that. And we are still green. Great, so that is our sample input working. So let's go to day 2.elm and we'll do actual. We'll get our quotes ready. Whoops, one too many. Okay, get your puzzle input. And this is going to be big again, so I'm probably going to have Windows moan at me. Yep. That's fine. Tidy that up there. Oh, looks like I have a bug in my key bindings. That's fine. Need to expose the actual. Okay, so now if we come down here and rather than saying day2.sample, we say day2.actual. And we run it. The test will fail. But hopefully we can take this and copy and paste that in there and submit it. Right answer. Excellent. Okay. Right. Okay. So we got the in those terms of the story, our top secret encryption method wrong. So second column says how the round needs to end. X means you need to lose. Y means you need to end in a draw, and Z means you need to win. Total score is still calculated the same way, but now you need to figure out what shape to choose so the rounds end as indicated. Okay, great. So really now the X, Y, and Z mean different things. This is another reason I like Advent of Code, because part 2 always makes you change the code a little bit, which I think is a good skill to practice and kind of more representative of real life. So let's go into our spec. Day 2, part 1. Let's copy this. Part 2, and we'll part 2. What do we expect now our output to be? Whoops. Where do I need to be there? 12. Okay. Oh, wrong window. Sorry about that. Close that. Is that what I want? Yeah. 12. Okay. Day 2, part 2. I think I have the other dog now trying to get into my room. Okay, both dogs now in with me, keeping me company. Okay, so day 2, part 2, we're exposing. So we still need to map over this, and we still care about this move to score that we get is useful, but now what we need to do is our charter move is different, because for our move we need to figure out what happens. So what was it? X was X that we lose the game, or we should lose the game? X lose, Y draw, Z win. Okay, so X lose, Z equals win. Okay, so we can do this. We can just change some types around here. So we'll say output equals lose or win or draw. This sounds very similar to this move result. So actually we could reuse that type. But when we're passing it here, we need to convert the A, B, or C into the actual move, and then R's into the desired what we need to do is we need to have a function called calculate R move, and it's going to take the other player's move, which is going to be a move, and it's going to take the character from the string, and it's going to return a move. So calculate a move, other move, desired char. Oops. And so I can say here rock, for example, because that's a move. So what we're going to do here is we're going to return calculate R move, charter move M2, and then we'll take M2. Oh, hey Keith Smith, thank you for the follow. So we're still changing the X, Y, or Z into a move, but to calculate our move, we now need to know what the other user is doing. So that's the move we just calculated, and we need to know the character we got. So we know what the other move is, so we can say case desired char of. Again, we're going to need to care about X, we need to care about Y, we need to care about Z. Anything else, I'm going to be lazy, debug.to fix me. And for now, just so Elm doesn't shout at me, let's just change this all to rock, rock, rock. And we've got an error somewhere. Oh yeah, and that's just random typo. So what we need to do is we now know X is loss, Y is draw, Z is win. So if it's X, what we can do is we can swap based on the other move. So case other move of. So X means we need to lose. So I'm going to get all my rock, paper, scissors mixed up. So if they're playing rock, we need to play the thing that loses to rock, which is scissors. They're playing scissors, we need to play the thing that loses scissors, which is paper. If they play paper, we need to play the thing that loses paper, which is rock. Okay. I do know how to play rock, paper, scissors. If it's a Y, then we want to draw. So in this case, what we can do is just respond with other move. We need to literally match their move. And if it's Z, we need to win. So in this case, if they play rock, we need to be the thing that beats rock, which is paper. They play scissors, we need to play rock. They play paper, we need to play scissors. And I think that is it, because we're now just adapting our code to calculate our move. Okay. Day 2 is failing because we're using day2.actual. So let's change this to sample. We're still getting 15 rather than 12. Okay, so that would imply that I'm doing something wrong. So calculate our move, we should play the thing that makes us game. So if we need to lose, is the X mean we need to lose, or does it mean our opponent needs to lose? Actually, have I got it the wrong around? X means you need to lose, Y means you need to draw, and Z means you need to win. Okay. Cool. Okay, so and if we need to win, rock plays paper, rock. Paper beats rock. Rock beats scissors. Scissors beat paper. It's why we match their move. Oh, I've been changing day 2 part 1 rather than day 2 part 2, which is very annoying. So change that to sample. Let's actually make this part 2 and we'll make this part 1. And they're both success. Okay, great. So if I change day 2, I'm actually going to have to move this below part 1, else that will really annoy me. What do I want to do? I just want to change this sample to actual. And run that. 12,091. Let's see how we're doing. Right, okay, great. That is day 2 done. As always, any Elm questions, please do just drop it into chat. Okay, right, day 3. So yeah, we'll do a bit of day 3. We'll see how we do for time. They do tend to get harder, the advent of codes. So at some point I'll probably get stuck. Hopefully we can keep going for a little bit yet. Okay, so Elf has the important job of loading all the rucksacks. Each rucksack has 2 compartments. All items of a given type are meant to go in exactly one of the compartments. Elf that packed failed to follow this rule for exactly 1 item type per rucksack. So presuming that means for every rucksack there is 1 item type that's in both compartments. The elves have made a list of all items in each rucksack, your input. They need help finding the errors. Every item type is identified by a single letter, lower or uppercase, but A and A, so they're different, okay. The list of items for each rucksack is given as characters on a single line. A given rucksack always has the same number of items in each of its 2 compartments. Okay, so we can split lift in half. I'm just going to zoom out here. I hope that's still readable for you. It just means that it's we're not wrapping these. In fact, we're still not wrapping them if I go big. Okay. Okay, the first rucksack contains all these items, which means its first compartment contains these items, and the second contains these items. The only item type that appears in both is lowercase p. Okay. To help prioritize item rearrangement, every item type can also be converted to a priority. Okay, so I thought we were just going to try and find the error. So I was thinking, okay, we have this, we split it in half. And that would be fine. And then we maybe use some set intersection to look for thing that appears in both. But we've got these priorities as well. So this is what I mean. Sometimes Advent code, they throw a lot of words at you, which is good practice to be able to sort of read through this and figure out what's going on. Okay, so lowercase items have priorities 1 through 26 based on their index in the alphabet. Uppercase priorities 27 through 52. The above example, the priority of the item type that appears in both compartments is okay. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of these item types? Okay, so I am right. The first thing we need to do is figure out the item that is in both halves of the input. So let's take this. I'm actually wondering about just literally doing it on 1 for now. Let's take the whole input for now. Okay. Let's go into day 1. New file called day 3. Elm. Inputs.day 3. Exposing sample. Okay, so we have that. Let's now write our spec. I'm going to copy you, paste, and we'll comment you out. Change 2 to 3. Day 3, part 1. Let's delete that test. Day 3, part 1. Day 3, part 1. Okay. Go in here. Day 3, part 1. It's going to end up returning an int. So day 3, part 1. Again, we'll just return 1 like I always do. We will expose that. Can I do that by an action? Expose function. Lovely. A value named day 3 already exists. I think these the Elm language server definitely isn't quite as good as some others. Unused pattern variable s, yeah, it gets really confused. Okay, so what are we actually expecting the result from our sample output to be? Some of these is 157. Okay. Okay, expected 1 to equal 157. Accurate, definitely wrong. Right, okay, so we're going to split them as always. So we're going to start with this. Day 3. Got sample. We need to import that. Let's just do that for a minute. 6, that's fine. Okay. So now what we need to do is we need to split the list in half. And I'm presuming they're always going to be even lists. So what we could do is we could figure out the length of the list, divide that by 2, and take that many items. That feels probably about right. I don't know if Elm has kind of list partition. I think it does in some form. Based on some tests, yeah, but we don't get the index there. Okay, I think we'll divide the length by 2 and take that many. Seems to make the most sense to me. So let's do rucksack builder. It's going to take a line, which is a string, and it can return maybe a tuple. Can items in a list be duplicated? Like if I represent each list as a set, Is that going to be an issue? I presume, yeah, there's multiple W's in there. Okay. Then does that matter? I feel like it probably does matter, so we shouldn't represent this using some data structure where we're going to lose data. So we will represent them as lists. So we'll return a tuple of list char for the two compartments. Okay. So for each one, we're going to do list.map rucksack. Again, we'll do let underscore equals in one. I'll do whoops. Okay, so our output is a load of rucksacks, which are empty. That's great. So we to split the input in two. First, items equals list dot take. We're going to take the first n items of the list. Let's do len equals list dot length input. Half len equals list length input divided by 2. Some brackets run there. Oh, I don't mean list dot length, do I? mean string dot length. Okay, that's used for floating points on that. Oh, we need to convert them to chars. So I'll say chars equals list. Oh no, sorry, string to list input. I'll say first half. Again, I will tidy this up, but I kind of like working through it like this. I don't think my brain is used enough to languages like this to be able to sort of create the nice pipeline straight out of the bat. Okay, so we'll do is list.take. The n is half the length from the chars. And what I'm going to do is say underscore debug.log. Okay, that looks about right. And the question now is, how do we get the second half? So there's take, drop. Okay, so we now want to drop. We want to do the same thing, but drop those first n members, and we'll get the second half. Okay. So what I'm thinking here is I'm now going to debug the first half with the second half next to it. And so if we now look at the day 3 input, the first one, for example, is V and ends in P. There's the V, and it ends in the P there. So that looks to me like roughly the right thing. Certainly good enough. So we have our two halves now. So that is our rucksack builder. So we want to return first half, second half. So our output is two tuples of lists, or list of tuple of lists. And now we want to find the one character that's common to both. I can't remember if there's a list include. Includes, or is it member? Whoops. Member. Okay, great. So we can do this either way around. We need to find, we know there will be one in each, I think. exactly one item type per access. So we know there is only going to be one character in list A that is also in list B. So it doesn't matter if we use list B and look in list A or vice versa. Oh, thank you. Oh, I don't know how we say that name. Cree. Thank you for the follow. So let's say char in both lists is going to take in our list of char, return a single char. And we can match this list 1, list 2. So we can say list dot, is it any? Char. I'm sorry, I probably have butchered the username, but thank you for the follow. I appreciate you coming in. Okay, so we say list dot member char list 2, and we'll apply this to list 1. Filter. Okay, this filter produces a list of characters. So yeah, we're filtering here to find members of list 1 that are in list 2. This returns a list because there could be lots of them. But then I'm just going to rewrite this. Sorry, list 1. We're going to pipe that into the filter. Then we're going to pipe that into list.head to grab the first one off. And then we're going to return maybe.with. Is there maybe.crash actually? And there might be. No, that's probably not. With default. Let's return an underscore, which is clearly wrong. Okay, so once we've mapped it through to build our rucksacks, we can map it through list.map. Char in both lists. Okay, that's looking good. We're grabbing single characters. Great. And then it's the priority of them, isn't it? Lowercase items have priorities 1 through 26. What I'm wondering here is, can we convert the character into its sort of number representation, and that will help us with the priority, rather than sort of, I don't want to write that list up myself. So we have is upper and is lower at least. Digit. To code, that's what I want. So we need to code, then we just sort of subtract some amount of numbers, which I can't quite remember what it is, because lowercase a needs to have priority 1. So let's just do a little bit of more printing. Debug.log a, and we're going to do, what was it? Char.to code a. Let's run that. 97. Okay. Divided this. Is this going to work? I mean, that gets us 1 for A. Then if I were to get capital A, whoops, I need to run it first. No, that gives us minus 31. So I don't know my character codes, as you can see. So capital A is 65. This is very confusing. Lowercase a is 97. Okay, so they're the wrong way round, effectively, in terms of getting our priority system. But we can know if it's lowercase or not. So let's say priority for char takes a char and returns an int. So if char.is is lower char, then what I want to do is do char.tocode char minus Was it 90? I've forgotten. Lowercase a is 97, so minus 96. Else, we'll do char.toCode char minus 64. Is there even an end? No, there isn't. Now they're both getting 1. Oh, of course, because for capitals we need to take away 64 plus 26, so 38. Okay. I feel like I'm going to be off stream and I'm going to realize there's a way easier way of doing this, and this is probably not good. But I think that's going to get us there. So anyway, we can find out, because now what we do is we map to the characters in both lists, and we do list.map priority for char. Which OS? This is Windows. This is the Windows terminal, but I'm running WSL, the Windows subsystem for Linux. So within this terminal, I'm effectively attached to I think it's an Ubuntu instance, but this computer is running Windows 11. Okay. And that's successful. Great. Okay, so we can take our output here. Let's tie this up, do our usual trick. And list.sum. Lovely. Okay. Yeah, the WSL is fantastic. It was, when that first came out, it was actually meant I could use Windows to work on, which is really nice. I don't use Windows at my job. Got given a MacBook there, but it actually means before I was dual booting Windows and Linux, and so I kind of have all my Vim and everything in Linux land. But now with this, I don't do that anymore. I just run Windows 11, and it's been really good so far. The Windows terminal is good. Once I'm in this environment, it just feels like Linux. I don't have to deal with any Windows specific stuff. So overall, yeah, I've been very happy with it. Okay, so exciting now. If we get our actual real life day 3 input, again, big copy paste, day3.elm. Yeah, I'm going to paste lots of text. That's fine. So we know this test will fail. We're getting 7,980. So let's go to code. 7,980 was it? Why didn't I just copy paste it? 7980, yeah. Right, excellent. Okay. We are another star in. So I feel like they're now going to throw something at us which needs to make us change. Oh, sorry, I've just seen I've missed a message. Yeah, I do get that, that it's nice to just run proper Linux straight up. For me, I found the effort of doing that and having to maintain and dual boot and stuff. I had Pop! OS installed, which I really liked. Then some upgrade went wrong and it failed and it went a bit messy. And in the end, I just decided I didn't want to deal with that. That's not a critique of Pop! OS. I don't think it did anything wrong. It's just one of those things. The upgrade went wrong. Don't know why. And yeah, I just haven't bothered. And basically, I haven't hit a point where WSL adds friction to make me think I want to maintain the dual boot. I can totally see why others would. Okay, right, so we'll get this part done and then we'll probably finish the stream for today. Safety, the elves are divided into groups of 3. Each elf carries a badge that identifies their group. Oh yeah, thank you. You're not interrupting me. I'm very happy to chat. In each group for 3 elves, the badge is the only item type carried by all 3 elves. Therefore, if a group's badge is item type B, then all 3 elves will have item B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other type. Okay. Struggling a little bit to deal with what that actually means, but we'll see. Someone forgot to put this year's updated sticker on the badges. All the badges need to be pulled out of the rucksacks. Nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one. So finding the one item type that is common between all 3 elves. Okay, each set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, I guess that's my input. Yeah, this input from above. Okay. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badges. In the second group, their badge item type must be Z. Priorities for these must still be found. Find the item type that corresponds to the badges of each 3 elf group. What is the sum of priorities? Okay, so now what we're doing is we're looking for unique item across 3 entire lines, I think. The only item type that appears in all 3 rucksacks is lowercase r. So the compartments and all that stuff seem to be less relevant now. So we need to work through our list, probably chunk it into 3 lines at a time. And then look for the only character. No, the only character that is in all 3 rucksacks. Okay. So for this test, we're looking for 70 as our final output. Okay, so let's go into our spec. I'll make sure I work in the main one now. Part 2. That's going to equal 70. Okay, so day 3. Part 2. Let's change this back to sample as well. Okay, right. So the rucksack builder now, it doesn't seem like we need to care about the 2 compartments of a rucksack. We need to now just... so we can still map over the rucksack builder, but we're just going to do... The rucksack builder, actually, thinking about it, it's just going to become string.toList. So we're going to change each rucksack into a list of characters. So now these are going to go wrong, so that's fine. And then what I'm going to do is I'm going to reduce, and every 3 items chunk up the list. So we're going to say chunk up rucksacks into groups. So we're going to be given a list of char as our input. And we're going to return a tuple of list char, list char, list char. So we're going to fold the rucksack left. So we're going to take it in our line and our groups. What do I want to do here? So we're going to have input that's like how do I do a comment in Elm? Is it like that? Not around to do a multi-line comment. Is this a comment? No. Alright, fine. So we're going to have input which is like X, Y, Z, A, B, C. And what I want to end up doing is creating this sort of set of X, Y, Z, A, B, C. Let's just for now return that. That doesn't error. So what we could do is, I'm wondering if Elm has a way to kind of group these lists by things, or kind of partition them in some form. I know we've looked at partition. I don't think it's going to do what I want it to do. No, so that's not quite what we want. Okay, so let me just kind of work through this in my head, see what I'm thinking of. So we're going to be on the current line, and we're going to have all our, let's call it groups. Yeah, let's call it groups, and we're going to have lists. So what I'm going to do now is I'm going to go through and I'm going to try and chunk them up into lists of lists. And the way we're going to do that, this needs to return a list. Fold left. Let's just string to list. This will be chunk access groups. And then what I'm going to do is just do list.length for now, just to mirroring. The argument is saying list of char, but piping it to a function expects list of char. I'm nesting my list somewhere. Okay. So this is a list of string. We then map that to a list of chars. Let's just return something to keep this happy. Let's see how we're doing. Right axis is definitely a list of chars. Line here is a list of char. Groups is a list of something. That's fine. It doesn't know what those are yet. It's actually going to be a list of lists. If I say, oh, hear the dog, I think the doorbell's just gone. Be back in a second. Okay, apologies. Yeah, the dog's not very happy with the doorbell or my dreadful Elm currently. Okay, so what I'm thinking here is when we get to a line, what we do is we say case groups of so what I want to do is take the first group, case list.head group of, it's just the head, that's fine. If it's nothing, which it shouldn't ever be, we'll just return the groups. If it's just the head, I'm going to see if the length of that list is 3. If it is, we'll shove it onto we'll create a new set of groups. If it's not, we'll append onto that. So we have the head, we'll say if list.length head. In fact, let's do case list.length head of. So if it's 3, we need to return a new empty list pushed cons onto the front of our groups. If it's anything else, we need to return the this line. In fact, sorry, that needs to be line, doesn't it? Oh wow, we've got some bugs there. In envins around line value outside range. Okay, let's do that differently then. So line pushed onto the head, and all that pushed onto the groups. Infinite type exception. Wow. Oh yeah, fair enough. Okay, so okay, unused pattern variable line. We're definitely using it here. So we're going to go over the groups. So we get a line. We look at our current groups. If the current group that we're dealing with, the head of it has got 3 things in, then what we do is we create a new line. We shove that onto all the groups. But if we do have that, then we take the current line and the head, and we don't shove onto groups. We shove onto the rest. Okay, I'm doing something weird here because it's getting all kinds of confused. Well, that doesn't need to happen, so that might be confusing it. You know what? I'm going to get rid of this string.toList. I'm going to say we're just going to take a list of string in here. I think that's going to help us. That's there. Then we have our dummy input here. Okay, Elm's compiler does not like me at all, does it? So if I just comment that out and just return an empty array, it's happy. So it knows that groups is a list of list of 8. It doesn't know what that. It knows it's going to be a list of lists, and it knows that line is a string. So that's good. And we're not getting the type errors now. If I bring that out, delete that. So head is definitely a list of something, right? I feel like it's one of those times where you've been staring at code and can't Can't see where the issue is. Okay. I mean, this is how we pattern match, yeah, on list earlier. First rest, yeah, okay. So let's, for example, let's just say what we're going to do is string dot to list on the line and push that on to the groups. So now rucksack is a list of string. Okay. Oh, we do. So I was expecting this to tell me that rucksacks is now a list of characters. Because rucksacks is a list of string. ToList takes a string, returns a list of characters. So result is a list of characters. Okay, so ToList line pushed onto group. Groups. Whoops. List of chart. Okay, right. That makes a bit more sense. So now let's go back to here. Still get this weird self-referential type. Okay, so head here is a list of chars, and we don't need this now run there. The left side is a list of chars, but head is just a list. Head is a list of chars. Groups is a list of chars, which means head is. Oh, do I want a list of lists? Oh, I get myself so confused with these blooming lists. Okay, so we have groups, which is a list. Each thing inside the group should be 3 lists of chars. So yeah, it's a list of lists of chars. This is maybe not the way I want to do it, but I think we're going to do that there. We do need that there. You know what we're going to do here is probably Bale. So Elm has a list extra, and I'm wondering if this will have a method to help us partition or split up this list into sets of a certain amount. It's going to really annoy me, and I'm probably going to revisit this and understand what's going on here. Okay, so far I'm not seeing a sort of handy helper that will just group. Okay, no. Okay, I don't really think any of those particularly seem to help us, sadly. Just want to like partition it or group it. Here we go. Split to groups of a given size. Excuse me. So groups of 3 is what we want. Okay, so we go to Elm. How do I install something? Is it Elm install Elm dash community? Yeah. Okay, so now we can import list.extra and we're going to expose. Is it groups of? What was the method called? Groups of, perfect. Okay, so we're going to take our input and we're going to map it into groups of 3. And this method is going to go. I'm going to just wish I'd never written that. Oh, I don't need the list.map, do I? I just need the literal groups of. Just get 2. Yeah, okay. So we now have groups of 3. So if we say let output equals in, say 1. Has my LSP died again? Yep, it has. Okay, so we now have that, which is good. I'm going to do a list.map string.tochar before we stick it in the groups of. Oh, it's not to char, it's to list. Okay, great. So now what we need to do is map this into unique char. Unique char is going to take in a list of chars. That's going to return a single char. And we know there are going to be 3 lists in here, I think. So input. So again, we can say case input of. So we know it's list 1 followed by list 2 followed by list 3 followed by the rest. Then we can do something. Let's just return A. Otherwise, we can do debug.todo. Should not happen. Have I got one more? Am I missing another list? Should not happen. Okay. Oh yeah, it won't be followed by the rest because there are only 3 items, right? So it would be that. Up at A, yeah, okay. So So the issue there was I was matching against that, which is I pull the first 3 items out, but then I also need the rest, whereas I don't want any rest. I just have those 3. Okay. So what we need to do now is find a character that is in all 3 of these lists. So we did char in both lists here. We're basically going to do something very, very similar here. So do list.filter char, and we'll pass that this one, and then we're going to do list.head maybe.with default underscore. So we can say list.member char L2, and is it and or is it list.member char L3? And I'm going to, again, quit Vim here. I'm not quite sure why the LSP is playing up so much. Okay, what's mode of this? So maybe to default. The argument is maybe a list of characters. Well, that's why I was taking the head here. Right, what's the error? Whoops. Get myself all confused with these lists of lists. Okay, that's better now. We do at least now have them all being the right thing. So why is char here a list of chars? It should be... I think I don't need that extra one here. This is correct. Yeah, this is a list of strings. So that's correct. A dev panda liking the look of functions in Elm, as in just the general syntax and defining them, or what in particular do you mean? Hello, by the way. Thanks for joining. Yeah, the syntax, yeah, it is nice. It takes a little bit of getting used to, but it does look good. I do like working with it. He says that being completely unable to work with it currently, which is driving me a little bit loopy here. Right, we have a list of strings. It's totally right. I'm going to pass that in to unique char. So unique char needs to take a list of string. So char is now a string. L2 is a list of strings. Okay, so that's good. So list.head. The argument is maybe string. So if I change that to that. Oh, but now we need to return a char. So let's just say it returns string now. Okay, that seems to be working. Okay, so if we now just log the output, should not happen. Ha! We're going down here. Is it because I don't want that in there? No, because then this ends up being a list of all the rest. So I do want... just kind of want to see what the length is. Am I losing the? I'm losing the log because we're getting to this crash. Let's just return an empty string here. Ah, input length is 2. Interesting. I thought the input length would always be 3. Let's just log that input. Oh, I'm so annoyed with myself. We're then doing unique char, but we need to map to do unique char. That's where I was going wrong. Because we're taking groups of 3, which gives us a list of strings. Sublist is a list. Yeah, a list of strings. Okay. Is it? Yeah, okay, so sublist is a list is a list of 3 strings. Right, I think we might be getting somewhere. So we now have 3 strings. What I'm going to do is I'm going to take this sublist and we're going to call unique char on string.toList sublist. No. Oh, whoops. Okay. Okay, so we can say let chars equals list.map sublist, and we'll do string.toList in, and we're going to just call unique chars. Okay, and chars here is unknown apparently. I don't really know why. Oh, because I got those wrong around. String.toList sublist. So chars is a list of char. That's really what we wanted all that time ago. List char. And we're going to say let underscore equals debug dot log input in the empty string. Oh, what an effort this has been. Okay, now we have 3 lists of characters, and we can do list.length input 3 and 3. Okay, right. So now what we can do is we can write that case statement. So case input of L1, L2, L3, followed by an empty list. This is the one we care about. Else we can just do debug.do2 should not get here. And in this case, we just want to, let's just return foo because that's technically a string. That's wrong. L3 is a list of chars, L2 is a list of chars, and L1 is a list of chars. Finally, I've got my list of chars of strings. mostly sorted. So what we need to do is do list.filter. We'll call this on L1, and what we want to do is say list.member L1, char and L2, and list.member char and L3. Let's just pipe this. L1 goes into that. Then we're going to pipe it to list.head. Expected string found maybe a char. That's fine. Yeah. So we need to change this string here to be a char. Maybe.with default. Unbelievable. How much effort did that take for me to get? The output is R and Z. That sounds about right. Once we have this map, I think we can steal what we did for part 1, which is these two. Put them on the end there. Output 70. That's good. And if this becomes output, I think we have actually done it. Okay, right, that is now passing. So let's just tidy this up. Let's get rid of that output there. And in here, I'm going to move this into, so we are going to map list.map string.toList. Let's just do this here. Okay, so we're going to do list.map string.toList sublist, and then all of that can be pushed in to the unique chars. Oh, and I don't need to call that because chars is the thing being piped in. If we run that, we are still successful. I think, can I do... I feel like that should work, but I think let's just leave it because clearly I'm getting myself confused in all the lists. Right, so this test is now passing. So if we now change sample to actual and run the test, it will fail. It's going to fail with 2,881, which we will copy into the advent of code. And that's the right answer. Oh my goodness. I feel like I will watch this back and realize that I was missing incredibly obvious things with those lists. I don't know if it's just me. In hindsight, I think I struggle to deal with things in my head when it's lists of lists of lists, or you start getting nested and you're passing these around. You're mapping over lists to generate new lists. I should have probably pulled it out into more helper functions, or I should have figured out a data structure where we had maybe what Elm calls a record, which is like a JavaScript object. And I could have represented each rucksack as like L1 list, L2 list, and then L3. A list which I find a bit easier to deal with than kind of nested lists, but maybe that's just me. I lost a lot of time trying to implement this groups of function. I think really that was probably what I should have just reached for straight away, gone straight into the Elm list extra to do that grouping rather than attempt to do it myself. But we did get there eventually, thankfully. So we have, yeah, it looks like a tree. Yeah, this code or just the way it kind of goes out and back in. We did eventually get there, which is nice. And right, I think that is a really good point to pause it. Been streaming for a couple of hours now. We do have 3 days done. I haven't even looked at day 4. Yes, I actually watched a friend implement this one, and I think this would be a really cool one to show off with the Elm parser library. So rather than regex this, we could parse it and put out different bits. But we will leave that for another time, and we'll call it there. So thank you very much to everyone who has joined and watched along and sent messages. Really appreciate it, and the people who've followed as well. I do hope that was at least partially entertaining, watching me bash my head against that final problem. I think some of that definitely was just rustiness of my Elm. I think if that was TypeScript or something, I could have probably done that much quicker. Currently hoping to stream a little bit on Wednesday early evening and then Friday as well. Oh, good. I'm glad it was fun. Haven't quite decided what we'll do. Maybe Wednesday we might do a bit more Advent of Code, or we might do some Vim Lua plugin development that I've kind of got on my list of open source things I want to do. And at some point we'll also return back to the Databot TypeScript AST generator stuff, which I've been streaming as well. So plenty of stuff, plenty of different things. People seem to have enjoyed Elm, so maybe we'll take a look at this one on Wednesday in Elm as well, and that will be streamed at approximately 5:30, 6 p.m. UK time on Wednesday. But the schedule is all on twitch.tv/jackfcodes. So with that, I will wish you all a nice day or evening, depending on your time zones. I really appreciate everyone who popped in, and thanks to all the first-time chatters for talking. Really enjoyed chatting with you all, and I will see you again very soon. Thanks.